Hello Year 8, so we're going to have a look at which equations have the same solution. So I think the easiest way to do this is just to solve each of the equations and then match them up at the end. So n plus 4 equals 19. The inverse of add 4 is subtract 4, so our solution is n equals 15. Next one, the inverse of subtract 8 is add 8. The inverse of subtract 9 is add 9. The inverse of multiply by 7 is divide by 7. The inverse of divide by 2 is multiply by 2. The inverse of add 6 is subtract 6. So those two are a pair. The inverse of divided by 3 is multiplied by 3. So these two here are a pair. The inverse of divide by 5 is multiplied by 5. The inverse of add 4 is subtract 4. So those two are a pair. Now, 4 times n, remember, multiplication is commutative. That means 4 times n is the same as n times 4. So the inverse of multiply by 4 is divide by 4. The inverse of divide by 5 is multiply by 5. This 2n, there's an invisible multiply sign in between those two symbols. So the inverse of multiply by 2 is divide by 2. So these two are a pair. The inverse of subtract 8 is add 8. So these two here are a pair. The inverse of subtract 4 is add 4. So that goes with this one up here in the corner. The inverse of divided by 8 is multiply by 8. So this one here goes with that second one there. And then the inverse of divided by 5 is multiplied by 5. And that goes with our first one up here. So today is part 2 of solving equations. And we're going to be looking at solving linear equations with the pronumeral on one side with several steps. So here is our first example. Now, I've got two things happening to the x here. I've got it being multiplied by 3 and then adding 10. We need to make sure we undo those things in the right order. Now, I could divide by 3 first, but if I divided by 3 first, I would have to divide the 10 by 3 and the 22 by 3. That would get quite complicated. I'd have some fractions involved. So let's see what happens if we do the alternative. The alternative is subtract 10 first. That would make things much easier. That would make the 10 leave this side, and I can subtract 10 from 22 very easily. So let's subtract 10. Because I'm doing it from my left-hand side, I do the same from my right-hand side. So I get 3x equals 12. Now my x is being multiplied by 3. The inverse of multiplied by 3 is divided by 3. Because I've done it to my left-hand side, I have to do it to my right-hand side. And I get x equals 4. When you're showing your working, you have to show steps with the equal signs in. It's up to you whether you write these operations by the side to show what you're doing. I'm doing it to help you understand each step, but it can make your working look a little bit messy. So if you're happy just keeping that in your head, then you do not need to write these parts at the side down. However, you do need to make sure that whatever you do to the left-hand side, you do to the right-hand side. Pause the video now while you have a go at this question. So, same as before, I could start by dividing everything by 2, then I'd have to divide everything by 2. It would work in this case, but I think it's going to be easier to subtract 10. It will always be easier to add or subtract something than it will be to divide by something. So let's start by subtracting 10. That gives me 2x on my left-hand side and 12 on my right-hand side. I've now got 2 times x. The inverse of multiplying by 2 is dividing by 2. And so I get x equals 6. Okay, next example. So the things that are happening here, I've got divided by 3 and subtract 10. I could choose to multiply everything by 3. I would have to remember to multiply this by 3 and this by 3, or I can choose to add 10. I'm going to choose to add 10 to both sides because that will make things easier. So on my left-hand side, I get x over 3. My right-hand side, I get 32. I've now got x divided by 3. The inverse of dividing by 3 is multiplying by 3. So I get x equals 96. Pause the video now while you have a go at this question. Same as before, I could either multiply everything by 2 or I could add 12. Adding 12 is easier, so I'm going to do that first. Because I do that to my left-hand side, I do the same thing to my right-hand side. So x over 2 is 34, and then x divided by 2, the inverse of dividing by 2 is multiplying by 2. Because I do that to my left-hand side, I have to do it to my right-hand side, and x equals 68. Here are the questions you need to do for the remainder of this lesson now. Make sure each step is shown. So each time you need to write the equation, write the first step in your working, write the second step. Everything will have, with the exception of 9a here and 7a and b, there will be 3 steps to each of the workings. Remember, if it helps you, you can use the algebra tiles on mathspot.com. So one of the questions I had was 3x plus 10 equals 22. So 3x, if I click on here to show the labels, 3x plus 10, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is equal to 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And so I can see here that these 10 match up with these 10. So I can get rid of these 10. Oh, I've lost my -1 button. And so I can get rid of the 10 from my other bar. One more. Then I've got 3 x's here. So if I split that into 3, then I can split this group into 3 parts. I can see that each part is equal to 4, so x equals 4. So you're welcome to use the algebra tiles there on MathSpot. These are your questions for the remainder of the lesson. Make sure you're marking your work and showing your working. Thank you very much.